Welcome to Brain Vision.
So we have a bowling ball. It is rolling with a speed of v initially, and it has, so we're going to call this v and v naught. It has a initial angular momentum of I omega initial. So if we analyze the forces being applied to it, we have mg, which is the weight. We have the normal force, and we have a static frictional force being applied to it. So if we want to analyze these as moments, this is going to be nt, this is going to be wt, it's going to be fkt. The first thing we're going to do is we're going to analyze. We're going to use our given. So we have 8.5 inches. That is the same thing as 0.7083 feet. So our radius is half that. So that's 0.35412. 5417 feet. We also have a initial velocity of 25 feet per second. We have a initial angular velocity of 9 radians per second. And we have a coefficient of kinetic friction of 0.10. So we want to find out at what time does the ball roll without slipping. So for the ball to be rolling without slipping, there is a equation that determines that situation. It is V is equal to omega times R. So V, the final V is going to be equal to omega F times R. So let's analyze the components in the positive y direction. So we have the positive y components. So we know that the acceleration is 0 in the y direction. So that means that the net force is also 0. And the net force is going to be equal to W minus N. Or rather N minus W, because this is positive y. So N minus W, so N is equal to W. Next, we're going to analyze the x components. So the plus x components. So we have a linear, we're going to look at the momentum here. We have an initial linear momentum of mv naught, and we are subtracting an impulse of fkt. See, this fkt is the impulse acting against the initial linear momentum, and this will result in a mvf. So we can solve this equation to get our for fkt. So we have mv naught minus mvf is equal to fkt. Now let's analyze the moments about, let's call this point G, so about G. What you're going to notice is that we have an initial angular momentum, which is in the negative direction. We're going to call clockwise the positive direction right now. So this is negative I omega initial plus FKTR is going to be equal to I omega final. So this is the impulse being provided, this is the initial angular momentum, and this is the final angular momentum. So what do we say this is equal to? So this is Vf over R. So we have the I, omega initial. Oh, and one thing we're going to do real quick is we're going to solve for I. So I is equal to 2/5 mr squared, right? So that, because it's a uniform sphere, so we have 2/5 times 0. Oh, we forgot to solve for the mass. So the weight, since we're using terrible imperial units, the weight is 16 pounds. So the mass is going to be 132.2 of that. So we have 16 divided by 32.2 is 0.49689 pound second squared per foot. And you can just look at this unit and understand why scientists despise the imperial system. So we have 2/5 times 0.49689 times r squared, which is 0.35417 squared. So our I has a value of 0.02493. And this is going to have units of pound seconds. So we have I times omega initial plus, we just determined that FKT is equal to this, so we have MV naught R minus MV final R equal to I times VF over R. So we're going to solve now for VF, and if we solve this equation for VF, we're going to get MV naught R minus I omega initial over I over R minus MR. And this is going to be equal to, oh boy, we have 0.49689 times V initial, which is 25 times R, which is 0.35417 minus 0.02493 times 9 all over 0.02493 divided by 0. God, I can't even fit it in here. 35417 minus 0.49689 times the radius 0.35417. So let's do that real quick. Or as quickly as I can, I guess. 2493 times 9 over 0.02493 divided by 0.357. Oh, I apologize. This should be addition. Yeah, that should be addition down there. Plus point, goodness, 49,689 times 0.35417. That gives us a final velocity of 16.95 meters per second. So next we want to find out so this is the answer to B. We want to find out the answer to A, which is what is the time? What is the time it's going to take? So we know that FKT, so this is just going to be, we're going to solve for it down here. We're going to have M, which is, M times V naught minus VF over the following. Times, so this will give us a T of 2.5 seconds if we plug everything in.